Hello viewers, I am Ashim, and in this episode we are going to explore virtual labs for our classes. As teachers, we often use labs to perform experiments, to conduct the various activities. Some of these activities and experiments are suggested by the syllabus. Often we choose activities to make our explanation, to make students understand better in the classroom. When it comes to the physical lab, performing experiments in a physical lab sometimes require a lot of planning and a lot of adjustments with the other fellow colleagues to get a chance to use the lab. On the other hand, viewers, using a virtual lab, we can perform experiments at a much easier and a convenient way according to our choice, according to our availability. It can be very conveniently used at any point of time in the classroom. So this way, we can enhance the quality of teaching subjects like science, maths, even language using virtual labs in the classes. So in the very beginning, let us understand what are virtual labs and some of the pros and cons of these labs in the classes that we use. Well, virtual labs in the classes come very handy, for a teacher to teach a particular topic in the classroom. These virtual labs, some of the virtual labs that we will be discussing in this episode, they have activities as prescribed by the syllabus, by the boards across a country. And let us see some of the features of these online virtual labs. So while talking about virtual lab, let us understand one thing, that these virtual labs help us to establish the interactive learning. These labs are based on the basic facts that it enhances interactive learning by students, because it allows students to perform experiment, of course in a virtual environment, but it is more like they get the feeling of actually performing the experiment. The only difference is that instead of doing it in the physical lab, they're doing it in a virtual lab. But the objective is the same, to get deeper understanding about the subject and the topic. So when they perform experiment through virtual labs, they are basically doing it in a simulated environment, making abstract concepts more tangible and engaging. Another important feature of these virtual labs are accessibility. As I was talking in a school setup, majority of the schools, they house only one lab for all the subjects, for all the classes, and we sometimes need to manage among the colleagues the time and the schedule, the routine that we follow for the lab. And beyond that, access is quite difficult because it collides with the schedule of other teachers. Where on the other hand, if we supplement our requirement with virtual labs, things can become smooth and very convenient for our classes. Students as well as teachers can have access to virtual labs at any point of time, anywhere, across devices, The basic idea is to not being hooked up or not restricted by the location or the time, that you have to follow a particular schedule only. Then only you have access to virtual lab. Physical lab. But on the other hand, virtual lab, it eliminates all these barriers for a teacher, even for a student. We can access to the facility at any time or from anywhere across devices, using a laptop or a smartphone. We can have access to these facilities and can perform these experiments in a simulated environment and understand the topic. These labs are very cost effective, yes, because since it is done in a simulated environment, so the expenditures that is required for buying expendables like those chemicals, salts, apparatus, glass tubes, beaker, thermometer, so many aspects, so many things we need to buy to set up a lab for the school. These gets eliminated. This is very cost effective. Virtual labs, it reduces that cost and become that, in other words, becomes a blessing for a teacher, to carry on with the experiments in the lab, in the virtual lab, in the classes. So some of these advanced experiments, which usually demands high expenditure, they can be easily performed using virtual lab in the class. So that is one advantage of using virtual labs, that it is really cost effective. Not only that, virtual labs are also very safe. See, in the lab, there is always a risk of chemicals getting spilled on the skin or on the hands. And children's, some of them are really scared of also to use these dangerous chemicals. And as teachers, we have to be always vigilant, to see that no student is misusing those chemicals. So along with the objective of teaching a particular topic in the lab, carrying out the experiments, the teachers do additional work of being vigilant so that these chemicals are in safe hands. The students don't misuse them, don't play around, and endanger their, safety. Virtual labs, on the other hand, is a very safe environment. Experiments can be done without getting, that teachers can focus only on the experiment and not on the safety always. So the work becomes easier for us. So they provide a risk-free environment or platform to conduct experiments, that maybe creates hazards in real life. So that part, when it is removed from any experiment, that the chances of hazards, then things become more open. The participations become more. So it encourages everyone to perform the experiment without the fear of accidents. So that is another benefit of using virtual lab. Well, in order to reinforce of concepts in the class, as science teachers would very well understand that to establish a particular law or theory or concept, it has to be supported by experimentations and performing activities. These activities not only, reinforce the concept, the idea, the knowledge in the minds of the students can also have a deeper understanding of the subject, which can be easily achieved by a teacher in the classroom if virtual labs are used. Through virtual labs, students can also collaborate and can engage themselves. They share their views. They learn as a team while performing these experiments. They explore as a group the various features of an experiment, the various outcomes that are intended as a learning outcome of that particular activity. Students can realize that as a group, they can collaborate They can collaborate with other students, they can collaborate with the teachers and perform this experiment and get a deeper understanding of the subject. So for this, to attain this, virtual labs can really help us a lot. Through virtual labs, a teacher can very easily bridge theory and practice. Certain theoretical aspects needs practical validation for a deeper understanding. This can be achieved through virtual labs. Students can connect the theoretical knowledge with the practical experience through virtual lab, so that the retention is better. They can comprehend things in a much better way. So to achieve all this, use of virtual labs is highly recommended in the class. Through virtual labs, contents can also be customized according to the need or according to the specific learning abilities of the students in the class. They can design or specific scenario or experiments, tailored experiments to suit their curriculum, or making the learning experiences highly adaptable by all the students in the class as per their learning style, as per their learning choices, or the previous knowledge on which these activities are performed. So overall, if we see things, virtual lab not only assists a teacher to get through the various topics in the classroom, but it also brings the element of hands-on experience, as well as the practical aspect, the linking of practical things with the theoretical part. So in this episode, we shall explore some of the features of O-Labs. It is developed by Amrita Vishwa Vidyapeetham in collaboration with CDAC, funded by the Ministry of Electronics and Information Technology. So in this episode, we are going to explore some of the features of this application. This is the virtual lab. Is very popular in the schools across the country. We shall explore some of its features. We'll learn how to use it for our classes. We shall also see another application called PHET, Simulations. This software also houses various activities which are beneficial for our students, which are beneficial for the teachers to transact a particular lesson in the class through various activity. And in both the softwares, we shall discover that activities are classified according to the stream, like according to the subjects like physics, chemistry, biology. These virtual labs can also be used for social science as well as language and mathematics. But in today's episode, we shall restrict ourselves to teaching science in the classroom using these virtual labs. These two are just examples. Viewers, you have the option to explore more and more virtual labs from the internet, and you can use it in the classroom. So from today, viewers, you can explore more and more softwares similar to OLAB and FAT, and get expert and use it in the classroom to transact various lessons, to impart the lessons efficiently in the class so that the student have better understanding. But for today, we shall restrict ourselves to OLAB and FAT simulation. So well, viewers, see you on the other side in the second segment, where we shall explore the features of these two softwares. Well, viewers, in this segment, let us explore some of the online virtual labs for our classrooms. So as discussed in the previous segment, we are going to explore the features of an application called OLAB. In order to use OLAB, first we need to go to the Chrome browser, type OLAB there, and when the search page shows OLAB, we click at OLAB, and that takes us to the landing page of this software. Well, this virtual lab has been designed keeping in mind the school syllabus under the NCERT prescribed syllabus. It has been designed in such a way that the subjects are segregated. As you can see, viewers, physics, chemistry, biology, maths, language, science, social science, computer, etc. But in today's episode, we are going to explore the facilities provided by OLAB for teaching science in the secondary section of our schools. Let us understand the basic features of this interface. So as you can see, this software, this was developed by Amrita Vishwa Vidyapeetham in collaboration with CDAC, funded by Ministry of Electronics and Information Technology. This hosts a number of experiments which we usually perform in the school, in the physical laboratory. The only difference is that when we do this here in the virtual platform, it gives us the freedom of doing it anytime and anywhere. Teachers as well as students can use this facility according to their own convenience and explore some of the experiments according to their need. So as I click the subject physics, it shows the prescribed experiments that we are supposed to perform in the school for classes 9 to class 12. So as you can see on the screen, that these are the experiments designed for class 12. Then as we go down, we have experiments for class 11. We go down further to get the experiments listed for class 10. And remember, these are the experiments related to physics, teaching physics in the class. So we have a number of experiments listed here, which are also prescribed by the boards across the country. And we shall explore some of these experiments one by one to have an idea how to use it in the school. So let's pick up an experiment from light chapter. It says to study refraction of light in rectangular glass slab. Let's perform this. So to use this, we just have to click and this page opens up. As you can see, viewers, the aim of the experiment is to study refraction of light in rectangular glass slab. Now, under this, various tabs are provided. Now, what are these tabs? Let us discuss them. The first tab, it talks about the theory for the experiment. Then next comes procedure, then animation, simulation, self-evaluation, references, as well as feedback. When we click at the theory, it displays the theory behind the experiment. The aim of the experiment called objective, the theory, supporting diagrams, as well as the rules. Some examples are also provided under the theory part. So teacher as well as students can go through the theory and can have an idea of what this experiment is all about. As we click on this part called procedure, here, this document helps us to understand how to go about the experiment, how to perform this experiment. So it has been listed in details how to go about this experiment as performed in the real lab. First, we need what are the apparatus which is required to conduct this experiment. So as it is written, a drawing board, rectangular glass slab, office pins, sheet of white paper, a protector, and sharply pointed pencil. Then the procedure is listed in details in stepwise, even the diagrams and the observation table. Now, today's objective is to conduct this experiment in a virtual environment using OLAB application. So after going through the procedure, now let us see how to perform this experiment in a virtual environment using this software. So for this, we have to click simulation and this window pops up. Yeah. So as it is visible, PQRS is the rectangular glass slab, and these yellow lines represent ray of light coming from the source. As this ray of light passes through the slab, it suffers refraction and bends. Well, to conduct this experiment, some of the help are provided at the top right corner of the screen. Show levels, so it shows all the details of this experiment, of this placement, of this setup. And with this slider, we can change the angle of incidence. With this, we can change the angle. So let us perform this experiment. So for this, we need to show the pins as we do it in a real laboratory, where 4 pins are used to perform this experiment. Well, in this application, this is the top view. We can also change the view. We can go to side view and it looks like this. It looks this way. So we'll continue with the top view and perform this experiment. So we can select a particular angle to start with the experiment. Say, let us fix the angle to be, say, at 20 degrees. So this is the first angle. So angle of incidence we have selected at 20 degrees. Oh, it is showing 21 degrees. Okay. So for this angle of incidence, the angle of refraction and the angle of emergence, everything is displayed simultaneously. So using this application, we can very well perform this experiment, whether it is in the class or at home, whether it is by a teacher or by the student. So it is conveniently done with the help of this facility. Let us explore some more experiments. So I'll continue with physics for class 10. Yes, so from this segment, we can study reflection in concave mirror. So as usual, the first thing that we need to go through is the theory part. Once we are done with the theory part, then we can see the procedure, how to perform this experiment. And once we are done with that, we can click the simulation to see how this experiment is done with an animated video. So once we click the simulation part, and then we have to click this button, play button. So as we can see, as the object is brought nearer to the mirror, how it affects the formation of image. So this is the animated video. The same experiment we can perform ourselves, but we have to click simulation. Yeah. So the same setup is displayed in the screen. So as you can see, a concave mirror is placed on the right hand side. A lighted candle is used as an object whose image is formed here. This is the observer. This is the location of the observer. And the position of this object can be changed by clicking at this blue dot at the left corner of this object, and we can slide this object towards or away from the lens. So for different positions of this object, we can find out the location of the image, the size of the image, as well as the nature of the image, whether it is forming a real image or virtual image, where is the image formed, how far it is from the mirror. Everything can be established through this experiment. Well, viewers, on the top right corner of this window, you'll see show help, show raise, and show labels. So you can click at show help, so it will tell us, it will guide you how to perform this experiment. When we click at show rays, it shows the rays of light. And as we click at show levels, even everything on the screen are described with names. So let us understand the formation of image for this object for various positions. So as we can see, a concave mirror is used where CP is the principal axis, C is the center of curvature, and F is the focus, the focal point of this mirror. Right now, the object is placed beyond C, and for this, as we can see, the image is formed between C and F. So to change the position of this object, we have to click at this blue button and drag this object. So let's bring it at C. So as I bring the object at C, we can see that when the object is placed at C, the image is also formed at C. The sizes are equal, but the image is formed is upside down. That means it is an inverted image, which tells us that it is a real image. So for this particular position of an object for a concave mirror, the image formed is a real and inverted image. The image is also formed at C, and the size of the image is same as the size of the object. Let us see for a new position now. So for this, we click at the blue dot again, drag the object. Now I have placed the object in such a way that it is located now between the center of curvature and the focus. For this position of the object, the concave mirror forms an image which is enlarged, which is inverted, and formed beyond C. As you can see, that this is the image which is formed beyond C. It is magnified as well as inverted. This way, we can check new positions. So let me now try it for F. When the object is positioned at the focus, where is the image formed? As you can see, the image is off the screen. That means the image is formed at infinity, hence it is not shown here. Let's drag this object further towards the mirror. So now the object is between the focus and the pole of this mirror. For this position, the image is immediately formed behind the mirror. See the position of the image, it is formed behind the mirror. This time the image is upright. That means it is a virtual image. It cannot be taken on a screen. The size of the image is bigger than the size of the object. So, well, using this application, we can perform this experiment to understand the formation of image by a concave mirror. Like this, we have various other experiments to perform for our student in the school. So let us pick one experiment from, let us explore an experiment from chemistry. So as I told before, O-labs cater to the needs of the experimentations from classes 9 to 12. And in today's episode, we are focusing only on the secondary section, that is class 9 and 10. So from class 10 syllabus, let us choose this experiment called properties of acids and bases. So through these experimentations, we can establish a link between the theory and practicals in the class, and students get a deeper understanding of what are acids and bases. So as the landing page of this experiment shows, theory, procedure, animation, video, simulation, self-evaluation, resources, and feedback. Well, these virtual labs come with a very wonderful option of self-evaluation. A student, after performing the experiment, after getting an understanding of what is this all about, can take up the self-evaluation and can test his or her understanding through the questions that will be asked through self-evaluation. Well, let us understand properties of acids and bases using O-lab. So as the objective says, to study the properties of acids and bases, hydrochloric acid and sodium hydroxide, by their reaction with litmus solution, zinc metal, and solid sodium carbonate. So this is the aim of the experiment. The theory part is described here. One can go through this theory part to understand what it all means, what it is all about. Let's straight away go to the procedure part. Here, the details, how to conduct the experiment is listed, along with the supported diagrams, levels, the apparatus that will be used for the experiment, and the chart. So once we are clear with the procedure, then we can select simulation, and here we can perform this experiment. So let us see, on the left hand side window, you'll find the basics of the experiment, the criteria of the experiment, and on the right hand side screen, the demonstration screen is displayed where we can perform this experiment. So as you can see in the window, a beaker is there, 2 test tubes with litmus solution. One is red litmus, the other is blue litmus. And with this dropper, we can select the solution and drop it into these test tubes one by one. So from the left window, we can select sample 1 or sample 2 or sample 3, etc. So to perform this experiment, this beaker contains sample 1 and whose nature we are going to test, whether it is an acid or a base, using litmus solution. So for this, we choose the dropper. So in order to choose the dropper, we have to click at the dropper, bring it over the beaker and leave. So this dropper solution from beaker. After this, we take this dropper, put it over the first test tube and release. We can repeat the process, take the dropper, bring it over the beaker, pick up solution, leave it to the second test tube. So as we can see that when we added the solution to the first test tube, red color changed to blue, whereas when we added the same solution to the second test tube, the color remains unchanged. This suggests that the solution that we added is basic in nature. To verify this, we have to click at these two options, the result options. It displays acid and base. So the moment I click at base, because we discovered that it is a base, so it shows the confirmation that yes, it is a base, it's a basic solution with some information given here that the given sample is a base that turns a red litmus solution to blue, but does not affect the blue litmus solution. Similarly, we can perform this experiment with zinc metal. We can test the nature of a solution, whether it is an acid or a base, using zinc metal. So as we can see in the setup, a test tube, phenolphthalein solution, as well as a sample solution. So to perform this experiment at any point of time, we can click at Help button on the right hand side top corner to get how to go about with the experiment. It is all explained with the Help menu. So if you are confused while performing this experiment virtually, we can click at this Help button. It will guide us, it will tell us how to go about with the experiment. So when I click this, it suggests that first I have to take the sample beaker over this test tube, which already contains zinc metal. So I have added the sample solution into the beaker. Now it's time to add phenolphthalein solution. So to add phenolphthalein solution, just like the way we picked up sample beaker, we have to pick this with the cursor. We'll have to just click at this beaker and lift it and take it over the test tube, and the solution will be automatically added. So as you can see, the color of the sample solution has changed to pink. Now what does that indicate? On addition of the indicator phenolphthalein, the solution has changed its color from colorless to pink. What does that indicate? What is the nature of the sample one? So in the results section, there are two options given, acid as well as a base. So whether it is an acid or a base, you can click at both of them and see whether it's a correct option or a wrong option. So I'm going to click at acid. So as you can see, it is a wrong option. That means the sample one is not acidic. So let's click at basic part. Yes, it shows the correct option. That means sample 1 is basic in nature, which changes its color to pink in presence of the indicator phenolphthalein. And some information are also flashed here. The given sample and sodium carbonate are bases, so they don't react to form an alkaline solution. Phenolphthalein produces a pink color in alkaline solution. So using these features of OLAB, one can easily perform the prescribed experiments or activities and can gather in-depth knowledge about the topic. Like this, we have other segments of the science stream like chemistry, biology, even maths are there. So as we are exploring this lab facility only for science subject in this episode, so this way we can continue our exploration. So here I would like to say everyone that you should try this application, explore the various features for the various classes one by one, get used to how to perform this experiment, and then we can take this to our classrooms and we can demonstrate in front of the students. And we can also encourage the students to perform these experiments at home to understand better about the subject. So like this, various experiments for classes 9 to 12 are listed here, are provided here. We can click at any one of them and explore the feature one by one. Even for class 9 chemistry, these are the experiments like we can find out distinguishing between solutions, boiling point of water, melting point of ice, etc. All these experiments can be performed in a very convenient way. Whenever we find time, we can use it. So that restrictions of using the physical lab in the school, where we have to really have a arrangement between the various teachers teaching science across the school to get an access to the lab. This, on the other hand, gives us that freedom that according to our need and requirement, we can use it anytime, whether it is in the class, after the class, or we can ask the students to perform the same experiment at home. So, well, viewers, this is one of the virtual lab. Let us now explore another virtual lab, which is called FAT simulations. So for this, we'll have to go to the search bar and type PHET, FAT, and then the option comes FAT simulations. So as we click, the search page shows on top the FAT simulator page. We can click here. After clicking, this is the landing page of FAT simulation. This is another application which also provides opportunity to perform virtual experiments. So this is the landing page of that software, where you can see the simulations, all simulations, category wise also we can select like physics, maths, statistics, chemistry, earth and space, biology, etc. So to begin with, we can see that category wise the experiments are segregated. So we are going to click here, explore our simulations, and this window pops up. So it lists experiments under physics, maths and statistics, chemistry, earth and space, biology, etc. We can also use filter. We can also use filter to have customized result, what we actually looking for. Suppose we are looking for some experiments from chemistry. So we click at chemistry, we check this. So whether we are looking for general chemistry or quantum chemistry. So right now I'm looking for general chemistry. So I should deselect quantum chemistry. So all these experiments which is on the display are from general chemistry. So as you can see, these experiments are titled density, build a molecule, diffusion, gas introduction, gas properties, experiment on gas properties, energy forms and changes, etc. Let us see how it works. So let us understand how this activity, this experiment on diffusion works. So for this, I have to click at diffusion. As I click, so this window opens up. So it talks about diffusion. So we'll just have to click this play button. So we click at play button, and this takes us to the simulated environment. So this is the window to understand about diffusion. So on the right hand side panel, we can just choose number of particles, two different types of particles, blue particle and red particle. So we can choose certain number of blue particles and certain number of red particles. So with this slider, we can change the number. So I just chose 30 blue particles on the left chamber and say 20 red particles on the right chamber. But as you can see, there is a divider in the chamber, that green line, so which is stopping the molecules from getting mixed up or getting diffused. So once we remove this, let's see what happens. So there is an option called remove divider. So as I remove the divider, you see how diffusion is taking place between these two types of particles represented by blue color as well as red color. So as you have seen, we started with blue colored particles on the left chamber and red colored particles on the right chamber. But once the divider was removed, how these particles mixed up throughout the chamber, and this is what is called diffusion. So with this activity, we can very well understand and explain the students the phenomenon of diffusion in the classroom. So this is one such activity. This button is to start or stop the activity. This button to refresh it. So as I click this, the experiment gets refreshed. So again, we can choose certain number of blue particles and red particles, and we can restart the experiment. Now let us see some more feature of this application. So there is another activity called states of matter basics. So it talks about the basics of states of matter. Let us explore this activity. So after clicking that, so this we have to click this play button, and fat simulation takes us to this particular window. So since we are doing the basics of the states of matter, so let's click at the states. So this is the window. So as you can see, this window on the right hand side, we can choose the type of matter: neon, argon, oxygen, and water. So right now, water, let's choose water, or we can choose neon as a gas. Here's a thermometer, and the temperature right now is showing 14 Kelvin. So at 14 Kelvin, neon is in solid state. So we can click at the liquid state and see how liquid neon looks like. And at the same time, the temperature has increased from 14 to 28 Kelvin. The moment I click at gas, so at 56 Kelvin, neon changes to gas. Well, so using this activity, we can explain or demonstrate the students how the particles of matter behave in the three different states: solid, liquid, and gas. This activity also helps us to increase the heat content of this substance or decrease. So we can supply heat, we can also take away heat from the system, and see the changes, observe the changes that takes place as we supply heat or take away heat from the system. So using this experiment, we can establish a link between the theory and the practicals in the classroom using the virtual environment. If we select another substance, say water, let's see how solid water looks like. This is how solid water looks like. This is how the particles of water behave in the solid state, that is ice. In the liquid state, it is in the fluid state. The particles behavior can be observed very easily from the window. And then the gaseous state. This is gaseous water. So for all the different states, we can check the temperature from this thermometer: liquid state, gas state. And we can also increase or decrease the heat of the system. So well, like this, there are plenty of experiments, plenty of activities that are provided by these virtual labs. We need to sit down with them, get used to these activities, and carry this forward in the classroom to help our children learn better. Thank you so much.